Another way of solving differential equation is what we call as exact equation. Okay. Now, remember in our differential equations, if the equation is in the format of mdx plus ndy is equal to 0, then we have used separation of variables. And then another methods of solving equations are we have homogeneous and then or homogeneous functions. We use substitution, and then this time exact equation. Now, in a given form, mdx plus ndy equals 0, if we have here, if the partial derivative of m with respect to y, okay, is equivalent to the partial derivative of n with respect to x, then the equation is exact. Okay, so in other words, first, if we have our differential equations, and then we have to identify our m and then n. Once we identify our m, we will check by using partial derivative of m with respect to y. So if we take the partial derivative of your m with respect to y, and then also n, we identify our n, and then take also its partial derivative with respect to x. And if the result of this partial derivative of m with respect to y is equal to the partial derivative of n with respect to x, then we can say the equation is exact. Okay. Now, in solving exact equation, uh, we will be using partial derivative. Okay, so now to illustrate this method of solving differential equations, we will have our example. So we have example, let's say example 1. Now, solve the equation, let's say 3x times xy minus 2 dx plus, let's say, x cubed plus 2y dy is equivalent to 0. Now, we're going to check first our m and n, or identify our m and n for this problem. Okay, so we do not know if this equation is exact. So, to determine if this equation contains exact equation, then we will check our m and n using this format. Okay, so our m, we will check our m. So for this case, our m is m dx. So 3x squared y, 3x squared y minus 3x times 2, that is 6x. Okay, and then our n is equivalent to x cubed plus 2y. Okay, now this time we will take the partial derivative of m with respect to y. So we have the partial derivative of m with respect to y. So if that is with respect to y, therefore the derivative of 3x squared, this x is considered as constant because this is with respect to y. So this is partial derivative. So that the derivative of 3x squared y with respect to y equals 3x squared. Okay, and then this one is considered as constant. There is no y variable, therefore the derivative of 6x with respect to y is equal to 0. So our partial derivative of m with respect to y equals 3x squared. How about n? So we will take the partial derivative of n with respect to x. So that is derivative, this is x, so 3x squared plus the derivative is considered as constant because we have here respect to x, therefore 0. So if you have noticed, we have now equal our partial derivative of m with respect to y is equal to partial derivative of n with respect to x. Therefore, this is exact equation. Okay, so this is an exact equation. Now, if this is an exact equation, to solve problems involving exact equation, we will have this one, integral of m dx. Okay, we're going to identify our integral of m dx and also integral of n dy. However, on this part, we disregard those terms with x. Okay, so we will start now our integral of m dx. Now, the integral of m dx, our m is equivalent to 3x squared y minus 6x dx. Okay, so we have the integral of 3x squared y, that is 3x cubed over 3. This is 3x cubed over 3y. Okay, so we have here 3x cubed over 3y. Okay, so that is, we have to consider y as constant because this is the x. So we only integrate x squared, so that is x cubed over 3. Okay, minus this one, which is equivalent to 6x squared over 2 plus c. And then that is equivalent to, okay, cancel 3. We have your x cubed y. Okay, minus 6 divided by 2, that is 3x squared plus c. Okay, now how about n dy? So our n is x cubed plus 2y. Integral of x cubed plus 2y. Now for the integral of n dy, this part, we have to disregard those terms with x. So I will write here asterisk. We have disregard those terms with x. Okay, so in other words, this okay, dy, this x cube will be disregarded, so we will just focus only on 2y. Okay, so we will just integrate only 2y. So what is the integral of 2y? That is equivalent to 2y squared over 2 plus c. Okay, or that is equivalent to y squared, okay, plus c. Now, to our final answer is we have to add, so final answer, okay, our final answer is we have to add this one with the ndy, the result of ndy. And take note also, okay, so I will just erase that word. So we have to squared, we have to write x cubed y minus 3x squared. We have this one, 3x squared. And then this one is y squared plus y squared. And then yung c will be transferred to the other side, or we will make it as our uh, answer, which is C. So this will how we write our final answer. So again, we will just disregard this one, C. and then this one also, so that we will equate it as equals to c. So whatever is your outcomes here, x cubed y minus 3x squared, and then you have to copy this one, and then you have to add this y squared. Just in case, if your answer here, and then you have here, has the same variable, disregard also, especially those who will be repeating. So say for example, if we have here plus x, and then we have here plus x, so you need not to add x plus x. Instead, your final answer here is you have to add only by x, only one x. Just in case if your answer here repeats in your answer here. Okay, so you just add only one term. Okay, so I will erase this one. So our final answer is x cubed minus 3x squared plus y squared. Okay, so that will be our final answer. Okay, we have here another example for solving exact equation. Now, we have solved the equation 2x cubed minus xy squared minus 2y plus 3 dx minus x squared y plus 2x dy is equal to 0. Now we have to identify what is our m, what is our n. Now for this case, it follows this format, and we know that m is a partner of dx, so this will be our m, and then n is a partner of dy. Okay, so we have our m, we identify our m, so we have our m, which is equivalent to 2x cubed minus xy squared minus 2y plus 3. And then our n is equivalent to negative times positive, that becomes negative x squared y minus negative times positive equals negative 2x. Okay, so we have here our partial derivative of m with respect to y, which is equivalent to, so partial derivative with respect to y, so there's no y, so this is considered as constant. So we have this one, we have negative 2xy for this case. Okay, 2xy minus this one, minus 2y with respect to y, partial derivative, that is minus 2. Okay, how about our partial derivative of n with respect to x? So with respect to x, we have this one with respect to x. So that is negative 2xy. So we have negative 2xy minus derivative, that is 2. If you have noticed, they are equal, therefore exact. Therefore, exact equation. So if that is exact, then we have to identify our m dx. So this is a process in solving exact equation. We take the integral of m dx, which is equivalent to integral of m dx. So we have the integral of m, which is 2x cubed minus x y squared. We have this one minus 2y plus 3 dx. So that is equivalent to the integral of this one is x to the fourth over 4. So times 2, that becomes x to the fourth over 2. X to the fourth over 2. This is supposed to be over 4, but you have here your 2. So 2 over 4, that is 1 over 2. So we have this one. Minus this one, integral of this terms dx. So the equivalent now is x squared over 2y squared. So minus x squared over 2y squared. So you will just integrate x, consider this one as constant. And then minus 2y, this is dx. So consider this one as constant. Okay, so you have negative 2xy if we integrate 2y dx. So consider 2y as constant. So that integral of dx equals x. So negative 2xy. And then integral of 3 dx equals plus 3x. Okay, so we will no longer write c plus c. Later on, we will write plus c. And then the integral of n dy. Okay, so our n dy, we have our n, that is the integral of negative x squared y minus 2x dy, which is equivalent to 0. Why is it 0? Because your terms here contains x. And this one has an x also. Therefore, automatically, you cannot integrate this one. That is in exact equation. Solving exact equation. Once you have x in your terms here, you will disregard the integration. Okay? So 0. Therefore, our final answer is this one. And if you have here a fraction, we will multiply it by 2. Okay? We will multiply it by 2. So that we have, supposed to be, we have our times 2. I will multiply already this one by 2. This whole equation. Okay, so we have x to the 4th minus x squared y squared minus times 2, that becomes 4 xy plus times 2, that is 6x, which is equivalent to c or c sub 1, wherein c sub 1 is equal to 2c. Okay, so you have this answer as your final answer. Okay. Sorry. Okay. Or you can write c sub 1. That is all about exact equation.